Robots Are Coming, a video featuring a lecture from Nick Hawes held at York University Festival of Ideas 2016, an event sponsored by the IET North Yorkshire Network. Dr. Nick Hawes is a reader in Autonomous Intelligent Robotics in the School of Computer Science at the University of Birmingham. His research applies techniques from artificial intelligence to allow robots to perform useful tasks for or with humans in everyday environments. He is particularly interested in how robots can understand the world around them, how it changes over time, and how robots can exploit this knowledge to perform tasks with more intelligence.
So my day job, my job is I'm a lecturer, but my research work is on the application of artificial intelligence to make robots do smarter things. Come in. Before I get started, I just want to show you some of the stuff I'm working on right now. We'll come back to this a bit later on. These are some robots that are part of a project called Strands, which is a European-funded project, where we're in charge of putting robots Our research topic is putting robots into everyday environments, such as offices here at the top. So this is an office in Tewkesbury, and hospitals like this. So this is a care home in Vienna, where we're putting robots in to assist the staff there in various ways and provide information. So we're really looking at putting robots in everyday environments with non-expert users and trying to meet the challenges of the technology to develop it. I should say that we don't build the robots, and all the stuff you see in this talk is about software. It's about programming robots, and I'll motivate that a little bit later on. So the bodies of the robots you see here are not particularly interesting to me. It's what they can do, it's their capabilities, it's their artificial intelligence that's interesting.
The return of the machinery question, first posed by economist David Ricardo in 1821. It concerned the opinion entertained by the labouring class that the employment of machinery is detrimental to their interests. The question is back with a vengeance in the guise of the rise of artificial intelligence, that's AI, because it threatens workers whose jobs were previously difficult to automate, from radiologists to legal clerks. It suggested that 47% of American jobs could be at risk by employing computer capital, economists speak for artificial intelligence, and that the annual creative disruption impact, again economists speak, could amount to $14 trillion, of which $9 trillion is in reduced employment costs. What's also being said is that the impact of AI is happening 10 times faster and at 300 times the scale of the Industrial Revolution. Though economists tend to be wrong, changes of this scale are bound to make a major impression. Martin Ford, an author, worries that the middle-class jobs will vanish with a severe effect on the economy, and that a wealthy plutocracy will shut itself away in gated communities guarded by military-style robots and drones.
So I'm going to talk about this topic, inside future robots, or what is it going to take to build the kinds of robots that we need for the future, the kinds of things that people are interested in using in the world. And it's motivated, or roboticists think of something called the 3Ds. Dull, dirty, and dangerous. So those are the kind of jobs that we're looking to give to robots, the kind of things that humans don't want to do because they're too dull, they're too dirty, they're too dangerous. And we'll come back to some of the things that robots might do in the future quite soon. And I'm not talking about science fiction, I'm not talking about way in the future, I'm talking about the next 5, 10, 20, 30, maybe 50 years of technology and application. Okay, so I'm going to sort of tell this story and kind of communicate, hopefully, where we're going to get to with future robots and the technology inside them by using a kind of a structure that we like to think of at Birmingham as the sort of 3 waves of robotics. It's the first 3 waves. There's going to be lots more waves at the bottom, but these are kind of a way of structuring the way you think about robot technology. Okay?
AI excites fear and enthusiasm, but it's worth remembering that many of the questions it raises have been asked before. So which jobs are most vulnerable? Of 702 occupations examined in a USA study in 2013, it was thought that 47% of workers were at risk. Identified were those in transport and logistics, like taxi drivers and delivery drivers, office support, like receptionists and security guards, and sales or services, like cashiers, counter clerks, telemarketers, and accountants. A similar study for Britain suggested that 35% of workers were at risk, and 49% for Japan. All significant figures. Predictions that automation will make humans redundant have been made before. Most famously, the Luddites protested that machines would destroy their livelihoods. Similarly, in 1964, a group sent Lyndon Johnson, then President of the United States, a memo stating that the combination of the computer and the automated, self-regulating machine would lead to an era that required progressively less human skill and threatened to divide society into a skilled elite and unskilled underclass. There was more hand-wringing in the 1980s when personal computers were first introduced.
So we can start with wave 1, which is, you can think of it as, wave 1 is when we built worlds for the robots, okay? So these are robots, and these are, when most people maybe think of robots that work for humans, or robots that work in human environments, maybe the first thing that comes to mind is something like this, and manufacturing robots, and this is a Kia factory, and these are robots making cars. And for me, these are actually really boring, okay? These are boring because there's no intelligence here, okay? We have to build worlds for the robots because the robots are really stupid, okay? In order to have a robot do a task, we want that robot to automate something. It has to be able to do it automatically. In order for a robot to act in a world automatically, it has to be able to understand the way the world is going to be arranged when it acts. So if that manufacturing robot is reaching out to grab a bit of a car or put a door onto a car, it has to know precisely where that car is, precisely where the door is, and then it can perform very, very, very accurate and smooth motions with the robot arm it's got. And the only way you can do that is by keeping the humans away. Because humans are a robot's worst enemy because they move things and they change the world. They're dynamic, okay? So here, for everything to run smoothly, we have to keep humans out of the way because they cause trouble. So it's not just manufacturing, there are actually quite modern and interesting applications of robotics that have a similar approach. Does anyone know whose warehouse this is?
Amazon.
Amazon, yeah. Oh, I think I put that there. Yeah. Okay, I'm going to get quite a lot today. Yes, this is Amazon warehouse. This is something called a Kiva system, and they're really, really exciting. It's an interesting application of something called mobile robotics, and we'll talk quite a lot about robots that can move around in their world quite soon.
Yet, in the past, technology has always ended up creating more jobs than it destroys because of the way that automation occurs in practice. Automation of a task, meaning that it can be done quicker and cheaper, increases the demand for human workers to do other tasks that have not been automated. ATMs might have expected to spell doom for bank tellers. In fact, the reduced cost of operating a bank branch meant that banks opened more branches due to customer demand, 43% more over the period that ATMs were introduced in the USA. What happened was the mix of work changed away from the routine tasks and towards more sales and customer service orientated tasks. Rather than destroying jobs, automation redefines them in a way that reduces costs and boosts demand. Between 1982 and 2012, employment grew faster in occupations that embraced automation, like graphic design.
So we don't want that. We want robots to work in human environments. Now this is a video of a robot called a PR1. It comes from Stanford. There's actually now a PR2, and we'll see a PR2 at the end. So these are some of the best robot bodies you can buy for doing robot work in the real world. So this is an amazing video, and it's totally fake. So when I say totally fake, the real achievement here is the hardware. Okay, so this research lab built a robot body, and they're here. They're showing what that body can do. But behind the scenes is one or more humans with joysticks and computers controlling every movement of the robot, and then this is sped up 8 times. So this is a vision of a future robot. And actually, this is also a bit cheap. This is a robot in a domestic setting. This is a household robot. They're probably going to be the last things we're going to get, because the cost-benefit trade-off of building something like this just to tidy your room and get you a drink from the fridge is really not going to make sense for most consumers. So they'll be appearing in much more kind of industrial areas before that.
So is AI going to be the same? Well, it seems so far. For example, the introduction of software capable of analysing large volumes of legal documents might have been expected to reduce the number of legal clerks. This isn't the case, because the cost of legal searches has reduced, so demand has risen. Automation of shopping through e-commerce with more accurate recommendations has encouraged more sales, and this has increased retail employment overall. It isn't possible to predict what jobs will be created, but imagine trying to tell our great-grandparents that their progeny would be video game designers, digital film editors, cyber security consultants. Nobody would have predicted these jobs a century ago.
Enough time, but we're going to think about how can the robot perceive the world? So how can it see the things it has to pick up? What should it do next? How does it decide to go and pick these things up off the floor, not those things? You know, how does it decide to plump up the cushions rather than pick up the things on the floor? And this is a crucial part of something called autonomy. So autonomy means you can control your own actions, you can choose your own future. Everyone in this room is autonomous, maybe to greater or less degree, depending on your age. But you still have some freedom to do something. And when the world is dynamic, our robots have to be autonomous to make their own decisions, to cope with the change that's around them. The factory robots are not really autonomous, they're just following a script. But we want our robots to be autonomous to cope with the dynamics of the world. So yeah, how does it decide what it could do next? How does it know where it is? Okay, this is a big question. We'll spend quite a bit of time looking at this because the answer is quite interesting, I think. And it underpins a lot of techniques that are used in robotics at the moment. So how does it know how near it is to the table? How does it know it's in the living room in the first place? How does it then know where it wants to go? So how does it know that it has to move around this side to pick up that bit of toy? How can it get there? And how can it interact with the world? So how can it physically change its configuration in order to pick something up and move it successfully? These are all very, very big questions, and they're just a fairly random or arbitrary selection of the kinds of questions you want to ask. But they represent, in some ways, different subfields of the science behind autonomous robotics. So each one of these questions maps to a discipline that people do research on. And again, there's many more disciplines, but these are some of the most important or some of the most fundamental, I think. Okay. So, moving on, so wave one, okay, we're locking the robots away, or we're locking the humans away from the robots. What we really want are robots to move into our world, okay? That's what that teleoperated robot was doing. It was moving into our world. And these are some examples. Maybe these three around this side are much more realistic examples of where we want our robots to be. We want to take them out of factories where they're bolted to the floor and put them in supermarkets and put them in warehouses and hospitals, enabling them to move around and solve problems and things like that. So once we unbolt them, we have to start asking this question: how does a robot know where it is? When it's driving around, how can the robot know where it is? Once it's unattached from the floor, it has to work out where it is. So this is a problem called localization. Exactly. So not only do you need to kind of sense your environment, you need to compare what you're sensing or what your GPS reading tells you to a map. And for most robots, working out where they are is a case of comparing their environment to a map. So this is a really simple map. I don't think it would ever work with a robot, but I'm going to use this to make a kind of, to explain how they work. So a map describes the space around a robot. They compare their position, what they can see with their eyes, although robots' eyes are terrible, and we'll get to that again later on. They compare what they can see, what they can perceive to a bunch of landmarks. We can look down on the map and we can see where the robot is. But the robot is in the map looking around, and it might have very bad sensors, very bad eyes. Imagine if you've just woken up and you can't really see and you can't tell which bit of the house you fell asleep in. That doesn't ever happen to me, I promise. And it's that kind of problem. You can't really tell where you are. And a robot's like that. So even though we're going to draw pictures of robots on maps, those robots aren't necessarily, they can't pull themselves out and look down upon themselves on the map, so they don't really know where they are. And the way they solve the problem of working out where they are is by playing a game. They play Guess Who. Okay? So whenever you see a robot driving around, you can just imagine that in its head it is playing Guess Who. So in Guess Who, you've got two players, and you're trying to work out who the other person has as they put another card there, and you're trying to guess who that card is. And you ask questions, right? You say, does the person have glasses? Does the person have a beard? Does the person have a hat? And you rule out possibilities based on the answers you get to that. And that's kind of how a robot works. Well, how a robot works out where it is. So it takes its map, and for the example we're going to use, it divides its world up into a grid, just like that Guess Who board with all the different faces. And then it does what I like the most about all of this, is it imagines itself in every single square on the grid. Okay? So maybe it's an egotistical robot. It wants to be all the people all at once. But it spreads itself out. Okay? And this is when we start to say the robot isn't in any of those squares. It doesn't know which square it's in. But it has to play this game of Guess Who to narrow down to its best guess about its location. So am I in a room with a pot plant? Okay? I have to ask. So who am I asking the question to? In this, who is the robot asking the question to in this case?
Probably its visual sense.
Yeah, it's sensors. So it's asking its eyes. So I've got a map. I'm looking at the map. Okay. Am I in a room with a pot plant? If the answer is yes, okay, I thought I was saying I see a pot plant, so then I can rule out the guesses in the room that doesn't have a pot plant. Not smart. So one of the problems is robots are really bad at vision. So seeing stuff, that approach relies on being able to see a pot plant or being able to see a person. This is an example. When I showed you those videos of robots driving around, one of the things the robots were trying to do was look at stuff in the environment and label it. And the robots only knew about a few things, such as monitors, and bottles, and mugs. And as you can see, these robots did terribly badly. And there are quite a few sort of technical reasons why it did so badly, and the people who wrote the algorithms that did this hate me for showing it all the time, but it makes me laugh. We use Sonar's work before. What we tend to use is laser. So the robots we use have lasers on them, and they're not going to triangulate based on external sources. They use the laser to measure the distance between them and features in the environment. So they have a map, but it's not the kind of map with objects and pictures. Instead, they're going to use a map of just obstacles, free space and empty space.
Focusing on the jobs lost misses a central economic mechanism by which automation affects the demand for labour. It raises the value of tasks that can be done only by humans. Those worried that automation will cause mass unemployment are succumbing to what economists call the lump of labour fallacy. This is that there's only a finite amount of work to do, so if you automate some of it, there's less for people to do. That's totally wrong.
One question is, what's the robot do next? I'm not really going to tell you how they do this. I'm just going to try and justify that it's an interesting problem. So this is a problem called planning. It's been part of artificial intelligence research since the 50s. And it's the problem about if the robot has to solve a problem, how does it choose what actions to perform in order to solve that problem? So if we think back to our tidying up robot, it's maybe got the current state of the world. This is the world it's going to tidy. So this is the desk with some objects on it. This is what's actually called the blocks world. This is a very famous artificial intelligence domain where we think about robots moving blocks on tables. Yeah, life's pretty boring in AI, unfortunately. And our goal here is to have a clear table. Okay, so that's the goal. We want to tidy up. So the robot can think, and the way this happens, the robot has to think about the possible future states of the world. It has to reason about hypothetical worlds that don't yet exist, that it could cause to exist. And that might be worlds like this. So maybe the robot could choose to tidy up this block, or maybe the robot could choose to tidy up this block. Those are sensible first steps in a plan to achieve your goal. But the big problem you have is, how do you make sure the robot doesn't pick up the block underneath the block on top? And how do you make sure the robot doesn't just like tip everything over? So in some ways these are still valid solutions. But you end up, when you're trying to get a robot to plan, there's a lot of knowledge you have to put into the system. So for example, some kind of naive or simple physics to say, if you've got two blocks, you should always take the one on top first. And in most examples, you wouldn't even tell the robot that it could tip the table, even though it would be capable of tipping the table. So although we want our robots to be autonomous and make their own decisions, a large amount of the research that you do when making these systems is about deciding which bits of the world you tell your robot about, and how you structure what your robot knows about in order to solve the problem. So these robots aren't just kind of creative, free-form things driving around doing what they want. They're typically very tightly structured in what they can do in what order. Okay, so we've seen wave 2. Wave 3, I was going to ask you a question before this. This is a giveaway, but what's the big problem with all the robots I showed you in wave 2?
They don't have any hands, not very dexterous.
They don't have any arms, okay? We've just shown you robots driving around. So the great thing about wave 1 is these robots can do really, really complex manipulation tasks. They can actually change the world around them by physically interacting with it. The robots in wave 2 just did things with sensors. They were driving around and sensing things. And even the logistics robots, they were just trolleys, right, that could drive themselves. What we really want is something where we take the best of wave 1, the best of wave 2, and get these robots to move around and actually interact with things physically. So there's lots of motivation for that. One example comes from the DARPA Robotics Challenge. So this was a competition that finished about this time last year, where people were building robots to go into challenging environments and physically interact with the world. So this was motivated by the Fukushima nuclear disaster, where I believe the story is there was one reactor that melted down, and inside this facility there was some other valve that if you could turn it, you would stop everything else melting down. That also might be an episode of The Simpsons, I get them mixed up. And the robots they had, they could send robots inside, but they weren't very effective, and they didn't have any manipulation capabilities. So this competition was about trying to design robots that could physically interact with the world as well as move around and get into challenging environments. So these are hugely impressive robots. If you haven't seen these before, go and Google the DARPA Robotics Challenge. There's a great video of all these robots falling over, which I haven't shown because it always upstages me. But these are all completely remote controlled. So they look really, really cool, but they are robots that are being elaborately remote controlled. They're like that robot at the beginning tidying up. There's no autonomy here. Also, things like manufacturing, to go back to the kinds of manufacturing world that made robots successful in the first place, there's lots of final detail in manufacturing that's still done by humans, but which could be automated. And there's interesting challenges about how you get a robot to actually move around a factory and perform very detailed manipulation tasks.
So who is right? Many technology types are the pessimists. They say it's different this time because machines really will take over all of the jobs. There'll be nothing left for humans to do. The optimists, mostly historians and economists, state that technology always creates more jobs. The truth is probably somewhere between the two. AI will speed up the current trend of computer-related automation, disrupting labour markets and requiring workers to acquire new skills more rapidly than before. It looks like the transition might be difficult, rather than a sharp break with recent history.